I hope it's recording.
Yeah,
I hope it's I mean, that's the sound and stuff. Okay. All right, so we're back, and now we're finally on air because we had panopto issues. But so let me finish up this problem here, and then I'll go back to the other problems, and then we'll continue on with our lecture here. All right, so this one, I mean, don't get me wrong, this one's a royal pain one to do without a calculator, but it's doable. So the question was, for what values of x, if any, does the function f of x equals 3x to the fourth minus 32x cubed plus 72x squared plus 10 have a local minimum? So I took my derivative, 12x cubed minus 96x squared plus 144x. I factor out 12x, gives me a x squared minus 8x plus 12. Remember, this is no calculator section, so it's going to factor nicely. X minus 6 times x minus 2, so that's 12x times x minus 6 times x minus 2. We said each factor equals 0, so 12x equals 0 gives me x equals 0. X minus 6 equals 0 gives me x equals 6. X minus 2 equals 0 gives me x equals 2. And I put them on a number line. To figure out max and mins, you want to put them on a number line. Now I pick some test values within my interval, -1, 1, 3, and 7, and I plug them into my derivative. Now the trick was, instead of plugging them into the big derivative all fold out, plug them into the factored one, because you don't care what the number is, you don't want to care about the sign. It's easy to plug in to figure out what the sign of these guys are. So when I plugged in -1, I got -12 times -7 times -3 into this part. Negative times negative is negative. When I plug in 1, I got 12 times -5 times -1. Positive times negative is positive. When I plugged in 3, I got 36 times -1 times 1, which gives me negative. And when I plugged in 7, I got 84 times 1 times 5, which is positive. Now, we're trying to figure out the minimum. Remember, I'm going down and then going back up. And then negative means this is my derivative, so I'm decreasing, increasing, decreasing, and then back to increasing. So, where are the minimums at? 0 is going to be a minimum because I go down and come back up, decrease and then increase. And 6 is going to be a minimum because, again, I'm going down and coming back up. So the answer is 0 and 6. So the answer to this problem is E. Does that make sense? And again, because we had some panopto recording issues on the computer here, let me go back to these first couple of problems and describe what we did. On the first problem was a classic limit problem. I plugged in my number and got 0 for 0. But remember, this is the final exam. We want you to use these high-tech terminologies here. So I applied L'Hopital's rule to draw the top over draw the bottom. Plugged in the number again. I got 4 over 8, which is 1/2, also known as 0.5. The answer was C. This problem here was a take derivative, so I used the product rule. Drew the first times the second plus the first time drew the second. When I took drew the second part, had to use the chain rule. Drew the outside, inside stayed at the same time, drew the inside. But in terms of cleaning it up, this is the only kind of cleaning up you have to do. The negative times the 3 is a -3, and put the x squared out front, and that matches the answer E. And of course, you know you're going to see several of these kind of problems on the exam. Find the equation of the tangent line of this particular function at the point 2. So the first thing I came up with was my point by plugging the x equals 2 into the original equation. The next thing I did was I took the derivative and then I plugged in 2 to get my slope of my tangent line, which is 5. And then I used the point slope formula. Remember, when you're doing a review of an exam and stuff, the other thing that you guys need to be doing is, as you're writing down your notes and the answers, write down the formulas that you're using. Yes, we're taking derivative, but don't forget, you need to memorize the point slope formula for finding the equation of lines and stuff. So there's lots of little algebra formulas you also need to know. And like I said, we just did this one to figure out local minimum. Finding minimums or maximums, take derivative, set equals 0 and solve, and possibly where derivative doesn't exist at, and draw your number line. That's going to distinguish between which one's a minimum point, which one's a maximum point when you find your intervals of increase and decrease. All right, what about next guy? Again, no calculator. Let's see here. Which of the following is the derivative? So if you're going to take derivative of this guy, this thing is e to the 3x squared plus 1. What rule would you use? Well, derivative of e to the x is e to the x, but this is e to a function, so you've got to use the chain rule version of it. Derivative of e to a function is e to a function times derivative of the exponent. So this would be e to the 3x squared plus 1 times derivative of the exponent, which is 6x. In terms of cleaning this guy up, They typically put the coefficient terms like 6x out front times e to the 3x squared plus 1. And the answer is, looks like A to me. Does that make sense? Look at the next one. I told you guys there's going to be a lot of derivative questions on this one. The next one is this. Which of the following is the derivative of x cubed divided by the sine of 5x? So, here we go. The derivative. What rule would you use to take derivative of this guy? Quotient rule. And again, I'm trying to drum this stuff into your head. So what's the quotient rule? Derivative of the top times the bottom minus the top times the derivative of the bottom all over the bottom squared. Derivative of the top, 3x squared times the bottom, sine of 5x. Minus the top, x cubed times derivative of the bottom. What's the derivative of sine of 5x? Chain rule. Derivative outside, derivative of sine is cosine. Inside, 5x stays the same times derivative of the inside, 5. All over the bottom, sine of 5x squared. And let me write it here so you guys can see what I wrote down. Sorry about that. Does that make sense? Quotient rule. So, and I kind of overdid my little divide line there. All right, but then let's talk about cleaning this thing up. This would be f prime of x is equal to 3x squared times the sine of 5x minus 5 times x cubed times the cosine of 5x over, and how do we write sine of 5x quantity squared? Sine squared 5x. And which one of these guys is my answer? The answer is C. Does that make sense? It didn't take long for them to, even on this section, throw a related rate at you guys. Let's take a look at this one. No calculator, remember. A particle is traveling around a circle, around the circle, x squared plus y squared equals 25. And x, y are measured in inches. Find the instant the particle is at the point 3, 4. Knowing that dy over dt is 15 inches per second, find dx over dt at this time. All right, so here we go. I got the equation x squared plus y squared equals 25, and our mission is to find dy over dt equals what? Given dx over dt is equal to 15 inches per second, and we've got the point 3, 4, which are giving me the x and the y. So, look at these units. Inches per second. Distance per time. This is a related rate problem. So what you're going to do here is you're going to take your equation and take the derivative with respect to time. Okay? So, what's that? Oh, you're right. I want to find, excuse me, thank you for noticing that. I want to find dx dt when dy over dt is equal to 15. All right, so here we go. But you're supposed to take derivative with respect to time. What's derivative of x squared? With respect to time. This is the chain rule action in progress. This is also implicit differentiation style. This is called related rates. You take derivative of the function, and derivative of x squared is 2x, but then you got to times by dx dt. Plus, what's derivative of y squared with respect to time? 2y dy dt. And here's where a lot of students will screw it up right here. What's derivative of 25? 0. And they will just put equal 25 because they forget to take derivative of it. Now, plug in what you know and solve for what you don't know. 2 times x. X was equal to 3 because of the point they gave us. dx dt is what we're trying to find. If you look at that, find dx dt. So you leave that as the variable. Plus 2 times y. Y was equal to 4. And dy dt is equal to 15 equals 0. Well, let's see here. 2 times 15 is 30. And 30 times 4 is, well, 3 times 4 is 12 with an extra 0, 120. So this gives me 6 dx over dt plus 120 is equal to 0. Solve for dx dt. I would subtract 120 from both sides. 6 dx over dt is equal to negative 120. Divide by 6 on both sides, and I get dx over dt. What's 12 divided by 6? Negative 2 with the extra 0. Negative 120 divided by 6 is negative 20, and this is a rate, so this is inches per second. So the answer is A. Does that make sense? The numbers we're plugging in are not overly difficult. These are numbers you should be able to handle without calculators is the point. Never said you weren't going to have to plug in numbers even on Part A with the no calculator. But they are numbers you can easily handle without. They should be nice numbers. Does that make sense? Take a look at number 8. Which of the following is the derivative of the tangent of x? Now, if you missed this one, you deserve to fail the class. That's just sad. Because this is pure memorization. What's the derivative of tangent of x? You got to know these guys. Straight up. What is it? Secant squared. That is just free points. Icing on the cake. The answer is D. You're done. That is a 10, not even that. That is a 5-second question. You understand that you're going to get through part 1 in about 30 minutes or so. Most people 30, but at most you're going to have is 1 hour. From 8 till 9, they'll let you do part 1. At 9 o'clock, you have to turn in part 1 and start part 2 and 3 because everybody else is waiting to use their calculators. You're not allowed to use the calculator on part 1, and no one's allowed to use the calculator until you're given the official word. All right? Take a look at number 9. Which of the following is the slope of the tangent line of y squared plus 3x squared plus xy equals 36 at the point 2, 4? Slope of the tangent line is at dy dx. So to take derivative of this mixed function where I have this relation where I have x's and y's all intermixed together, this is called implicit differentiation. You're going to take derivative of this entire equation with respect to x. What's derivative of what? So when you take derivative of x's, x's work fine. When you take derivative of y's, you've got to tack on times dy dx. So what's derivative of y squared? 2y, take derivative, but then the times, because it's a y variable, dy over dx. Plus what's derivative of 3x squared? 6x. No, and that's good because that was an x. How do you take derivative of x times y? What rule would you have to use? Product rule. Derivative of the first, derivative of x is 1 times the second y plus the first x times the derivative of the second. What is derivative of y? dy over dx. Derivative of y is 1, dy over dx equals, and what's derivative of 36? 0. Does that make sense? Now, if you want to, you can solve for dy over dx. That's fine. But when they want the derivative at a particular point, the easiest thing to do, and this is why you come to these review sessions and study this to figure out the easiest and most direct way, is I'm trying to find dy dx at this point. Go ahead now and plug in x is 2 and y is 4. Saves lots of time. So this will be 2 times 4 dy over dx plus 6 times 2 plus y, 1 times y is 4, plus x, which is 2, dy over dx equals 0. Now we're solving for dy dx. Well, 2 times 4 is 8 dy over dx plus 12 plus 4 plus 2 dy over dx equals 0. At this point, it's all about combining like terms. What is 8 dy dx's plus 2 dy dx's? 10 dy dx plus 12 and 4 is 16 equals 0. How would you solve for dy dx? I would subtract 16 from both sides. This gives me 10 dy over dx equals negative 16. And then divide by 10, and I get dy over dx equals negative 1.6, because all I did was divide by 10. That's easy math that I don't need with a calculator. Does that make sense? So which is my answer over here? Negative 1.6. The answer is C. Does that make sense? Questions? If I wrote too fast, there it is. All I did was plug in my numbers, and honestly, at this point, I just do a lot of this stuff in my head, but be careful. Watch the careless errors. I've seen your grades, and you guys are pretty much just like I was when I used to take this class, and that is chock full of places to make careless errors, so I wasn't paying attention. But there's a difference between an A student and a C student. A student catches its careless errors and takes its time. C student rushes through it because they got to have something to do or something or other. No, you don't. This is a calculus exam. Enjoy it. All right. Number 10. The derivative of a function f of x is given by f, and this is f prime of x now, the derivative of f of x is given by f prime of x equals 20x plus 6x to the 1/2. Find a formula for the function given f of 1 equals 25. They want me to find the function f of x. So, this is on that last material that we just covered. What do you call this? If they give me the derivative, I don't want the original function back again. Antiderivative or integral. You're going to integrate this derivative. So you're going to integrate 20x plus 6x to the 1/2 dx. Again, take your time. Think about, switch gears. This is the antiderivative or integral rules. So, 20 is a constant, leave it alone. What's the derivative of x to the first? Add 1 over add 1, that's x squared over 2. 6 is a constant, leave it alone. What's the integral of x to the 1/2? Add 1 over add 1, x to the 3/2 over 3/2. And don't forget, you got to have your plus c for your constant of integration. Clean it up. So your function here is 20 divided by 2 is 10, x squared. You with me? 6 divided by 3/2. When you divide by a fraction, you invert and multiply. So if I flip the 2 on top, that's going to give me 12. Divided by 3 is 4x to the 3/2 plus c. Now, keep going. I got to figure out what c is. F of 1 is equal to 25. So that means when I plug in 1, that'll be 10 times 1 squared plus 4 times 1 to the 3/2 plus c. That's supposed to be equal to 25. So, 1 to any power is 1, so this is 10 plus 4 plus c equals 25. 14 plus c equals 25. That makes c equal to 11. Does that make sense? Therefore, my final answer is f of x is equal to 10x squared plus 4x to the 3/2 plus c, but c was 11 after we found that initial condition. Which is answer which one? A. But honestly, if I wanted to save a bunch of time, now I'm going through every detail in this problem and not skipping any steps, I could have got this answer 10 minutes ago. Why? When I took my derivative, when I took my antiderivative, I got this equation right here, plus c. It's 10x squared. You see it? There's only one of these dudes that has a 10x squared on him. Must have been that dude for the answer. Does that make sense? And I didn't even have to solve for the plus c, but I went out of my way to give you the entire answer that this is correct. So pay attention to that stuff too. Kind of clues you in on zeroing on an answer, especially if you're running out of time. Take a look at the next guy. What are you supposed to do on the next guy? Evaluate the limits. First rule limit. Plug in a number. Here is a 10-second question. On your mark, get set, go. I'm going to plug in 2. 21 times 2 plus 2 over 7 times 2 minus 4. 21 times 2 is 42. Plus 2 is 44. 7 times 2 is 14. Minus 4 is 10. So what's my answer? 4.4. And I went way out of my way to plug in the numbers and show you all the details of this stuff. On multiple choice problems, you don't have to be as elaborate. I'm being elaborate for you, so I'm trying to show you all the details. But when you're doing it, just watch the careless errors. But you don't have to be as elaborate as I am in terms of plugging in the number and just double checking everything. But when it comes to the free response, that's when you become very elaborate. Does that make sense? Take a look at number 12. Which of the following is derivative? Well, this is derivative natural log. Well, derivative natural log of x is what? 1 over x. But this is not x, it's a function. Derivative natural log of a function is 1 over the function times the derivative function. Chain rule version of it. So here we go. The derivative of this guy is going to be 1 over 8x plus 3 times the derivative inside. Derivative of 8x plus 3 is 8. So this is just 8 over 8x plus 3, which is answer B. Does that make sense? Another 10-second question. All right, number 13. Evaluate the limit. All right, first rule of limits is plug in a number. Just to remind you guys, we're taking limit this time as x approaches positive infinity. So if I plug in a number, and this is for your benefit, that'll be 9 times infinity plus 3e to the negative infinity over 2 times infinity minus 5e to the negative infinity. What you've got to remember is e to the infinity is infinity. However, e to the negative infinity is equal to what? 0. Because the negative exponent puts you on the bottom, infinity's on bottom, make the term go to 0. So these guys are going to 0. And again, I'm going over elaborate here, but with 9 times infinity, well, that's pretty much infinity. Plus 0 is infinity. Over 2 times infinity, which is infinity, minus, here we go, 5 times a 0, well, that's 0, so it's infinity over infinity. You with me? So, infinity over infinity, what am I going to do? You got it. This is a L'Hopital problem. So, L'Hopital, take the limit as x approaches positive infinity of, derivative of the top. What's derivative of 9x? 9. What's derivative of 3e to the negative x? Chain rule, that'll be 3e to the negative x times negative 1. This is for your benefit. Divided by derivative of 2x is 2. Minus 5 derivative of e to the negative x is e to the negative x times negative 1. Clean them up. Before you plug in infinity, you always clean them up. L'Hopital rule. This will be equal to 9 plus, minus 3e to the negative infinity divided by 2 minus plus 5e to the negative infinity. 3 times the negative 1 is where the minus 3 comes from. Minus 5 times minus 1 is the plus 5. Now, plug in infinity. This will be equal to the limit as x approaches infinity of 9 minus 3e to the negative infinity over 2 plus 5e to the negative infinity. But as we just mentioned before, e to the negative infinity is what? 0. So this thing goes to 0, this part goes to 0. What are you left with? 9 halves. So the answer is 9 halves. Now, the professor that made up this exam was very excited by the fact that he loved decimals. What's 9 halves? Okay, you're going to make me divide it. Let's see. 2 goes into 9. Well, 2 goes into 9, 8, let's see, 4 times. 4 times, and 4 times 2 is 8. Subtract, you get 1. And then bring down your decimal here, 0. 2 goes into 10, 5 times. So that's 2 times 5 is 10, you get 0. The answer is 4.5. You should know 9 halves is 4.5. But remember, there was no calculator on this thing. But this professor that made up this exam really loved decimals. Every professor is different. They all have their little quirks. Does that make sense? Don't lose you guys anywhere. And if you notice this thing, I had 30 minutes of problems with Panopto up here, so we got started 30 minutes late. I still finished this thing in 30 minutes. How long do you have on part 1? 1 hour. After you're done with this thing, depending on your instructor and how they want things done, my students will come up here, turn in their part number 1, grab part number 2 and 3, and go back to your seat, fill out your bubble sheet, and continue to work. Problem is, no calculator. You will not be allowed to use a calculator until your instructor gives you the official okie dokie. When I tell you guys, hey, you can now use your calculator, that meant everybody in the classroom has done with part number 1. That's the way it works. So, I'm on part number 2, and I yet to have used a calculator. So, got out my bubble sheet, and let's get going here. Still no calculator, but I bet I can still do most of this thing without a calculator. So, here we go. Determine the value of A and B if they exist using the graph. Take the limit as x approaches negative 3. Let me blow this up just a little bit. You guys can see this a little bit better. Take the limit as x approaches negative 3 of A. Negative 3. Here's negative 3. Remember, as I approach both sides, where's the function going? Where's my function going? It's the y value. So understanding graphs. What number is this? These are hash marks. That's 1, that's 2, that's 3. Where is my value of my function going? It's going to 2. So A would have to be equal to 2. What is the limit as x approaches 2 from below of f of x? There's 2. X is 2. From below, I'm going down here. And as I approach 2 from below, what's my functional value that I'm approaching? 3. So A is equal to 2. B is equal to 3. The answer is E. I didn't need a calculator for that. Does that make sense? The idea of limits is as I get very close to this number, where is the functional value getting very close to? Even though there's a hole in the graph, where is that hole in the graph value going to be at? All right? Take a look at this guy. A cube is measured to have edges of 20 centimeters with possible error no worse than plus or minus 0.03. Use differentials to estimate the volume, the maximum error in calculating the volume. Well, that freaks people out because they don't remember differentials. Well, all right, so let's remember differentials. All right, so we have a cube. What's a cube? What's the special deal about cubes? All the sides, I'm going to call it x just to make it easy, are the same. We want to use differentials to estimate the what is it? Volume, calculating the volume. What is the volume of a cube? Length times width times height, but being a cube, the length and the width and the height, they're all the same. Yeah.
Sorry to interrupt. On the previous one, I just had a quick question.
Oh, sorry.
Still the same answer for B. I was looking at it, it says as x approaches 2 from the negative side.
Yeah.
It's, so it still is 3? Because I thought that was for the positive side.
No, there's from the negative side is below 2. Yeah, take the limit as x approaches 2 from below. There's 2. From the negative side of 2 is on the left side of 2. And where is my function going? Remember, limits give you y coordinates, y values. So as I'm below 2, I'm going up to 3. Does that make sense? If I take the limit as x approaches 2 from above, that would have been negative 2. Does that make sense? Okay. All right, back to this guy over here. Volume. What is the volume of a box? Length times width times height. But all the length and width and height are the same. I used the letter x just to make it nice. So what's my formula for the volume of a box? A cube, that is. X cubed. The formula for the differential is equal to the derivative of your function, whatever it happens to be, dx. And this helps us calculate the change in volume. Remember, the differential of volume helps us calculate the actual change in volume. And this should be in a squiggly equal to there, approximate. And this is my formula. You take derivative, d, whatever the variable is. In this case, I put x. So my differential is this. What is the derivative of x cubed? 3x squared and d times dx, times derivative of the variable. In this problem, what was the size? My x's, my lengths are supposed to be what? 20 centimeters. They told me that. But the error is this plus or minus 0.03 centimeters. What is that? That is the possible change in x that I can have for all my sides. Plus or minus 0.03. So, dv would be equal to 3 times x, which is 20, squared, times, officially plus or minus the 0.03. And so, 20 squared is 400. 400 times 3 is 1200 times 0.03. Well, I can do even better than that. I can do this. Let's see here. 3 and 0.03, that's be 0.09. Well, by this time I can use calculator. All right, so here we go. 3 times 20 squared times 0.03. Plus or minus, I get plus or minus 36. And what would this be? What would my units be? Just in case this is a free response question. Centimeters what? Cubed. This is the change in volume, and volume is measured in what? Cubic centimeters. Centimeters cubed. So it's plus or minus 36 centimeters cubed. The answer is B. Now, let's say, for example, I was not allowed to use my calculator yet because it's still before 9 o'clock and I'm working on this problem. You know what I do? I just leave it because I was number crunching and go on to the next problem until I am told that I can use my calculator, and then I'll go back and finish up these problems that all I need to do is some number crunching on. So, you will be most of you guys will be starting part number 2, but you're not allowed to have your calculator yet. That's okay. If you need a calculator, just wait on it. Just get the problem done. I have the answer. All I had to do was crunch out my number. I could have moved on and then just gone back to this guy so I can figure out which answer it is. All right? Take a look at the next guy. The function f of x has the derivative for each value of x, and g of x is equal to the square root of f of x. Well, that sounds important. G of x is equal to the square root of f of x. Find g prime of 2, given that f of 2 is equal to 25, and f prime of 2 equals 16. Do you know what this problem is? It's a web work problem. Okay? They stole this one off of web work. All right. So they want me to take derivative of this guy. Before I can take derivative of g prime at 2, I got to find g prime of x. G prime of x. First off, I don't do square roots. What's a square root? That's a half a power. Okay? So, I'm going to take derivative of this guy. Chain rule. Derivative of the outside. Inside stays the same. Raised to the negative 1/2 times the derivative of the inside. Does that make sense? Now, you can clean this up if you want to. I shall. Fg prime of x is equal to 1 over 2. A negative exponent puts him on the bottom, and a half a power is a square root. So this is the square root of f of x on the bottom times f prime of x. Well, we want to find g prime of 2. So what am I going to do? I'm going to plug in 2. That'll be 1 over 2 times the square root of f of 2 times f prime of 2. At this point, it becomes just crunching in the numbers that we know. What numbers do we know? This is going to be 1 over 2 times the square root. What's f of 2 equal to? 16. I'm sorry, 25. F of 2 is 25. Make sure you put it in the right spot. F of 2 is 25 times f prime of 2, which is 16. I don't think I need a calculator for this. Let's see what we can do here. 2 goes into 16 8 times. What's the square root of 25? 5. So what do I get? 8/5. Does that make sense? But look at my answers. What are my answers? Decimals. Why? Because the professor who made this exam up just loved decimals. Okay, so it's 8/5. What exactly is 8/5? Well, you can also, basically it's the same thing as 16 over 10, which is 1.6. That was B. Every professor who makes these things up has their own little gist on life. But are the questions overly difficult? No. They will be when you guys take the exam tomorrow, because the guys who took this exam thought the same thing. Last semester exam wasn't too bad, but one they gave us was awful. Too many decimals. Well, granted, yeah, they gotta love decimals. I won't argue that point. But it's just decimals. You guys are science majors. Get used to it. All right, let's take a look at the next guy. Oh, another one of these Newton's method problem, right from our last material here. Use Newton's method to approximate the function f of x, which is equal to x cubed plus x squared plus 2x plus 3 has a 0. Start with x1 equal 1 and find the first approximations, the second iteration and the third iteration, x2 and x3. Well, here's the deal. You got to have the derivative, which is 3x squared plus 2x plus 2. All right? And the most important thing about Newton's method is, what's my formula? Xn plus 1 is equal to xn minus f of xn divided by f prime of xn. You with me? What is my first x? What is my x1 going to be? 1. To get the next iteration, which will be x2, you plug in 1. It'll be 1 minus f of 1 over f prime of 1. Okay? So, and this is definitely going to be a calculator problem here, but I don't need a calculator yet. When I plug in 1 into my function, 1 plus 1 plus 2 plus 3. 2 plus 3 is 5, plus 1 is what? 7? So this is 1 minus 7 over, plug into the derivative. Plug in 1 here. This is 3, 2 and 2. That's 4, and 3 is 7. So what do I get? Well, 1 minus 1, which is 0. Which tells me what? x2 is 0, which means my answer is either A, B, or C. I can already eliminate some answers. Does that make sense? Now, we want the next iteration. x3, that'll be x2, which is 0, minus f of 0 over f prime of 0. Well, I don't need a calculator to plug in 0 into these functions. When I plug in 0 into my function, I'm going to get 3. 0 minus 3 over. When I plug in 0 into my derivative, I get 2. So it looks like I get negative 3/2. What's negative 3/2 also known as, because this guy loves decimals? Negative 1.5. So x3 is negative 1.5. Which is answer which one? A. And notice, if you got those derivative backwards type things here, it would have shown up here and you would have picked the wrong answer if you thought that Newton's method was derivative over the function. It's xn minus the functional value divided by the derivative. Know your Newton's method. Does that make sense? Did I lose you guys anywhere? All right, keep going. Number 5, here's one that was very similar to what they put on the last test. But be careful. Pay attention to what graph they've given you. Given the graph at the right is the graph of the derivative of a function f of x, so that the graph of y equals f prime of x. So this is the graph of the derivative, f prime of x. Which of the following statements is true about the function? This kind of a question, you don't have a choice. You've got to go through each one of the answers and kind of figure out which one is working. Which one is true? So let's see what's true. F is increasing between A and C. To increase, the derivative had to be positive, which means it's above the x-axis. This is above the x-axis, that's true. And between F and infinity. Okay, so these parts are true, that's checked. And concave up. Concavity. If I want concavity, concavity deals with the second derivative. But I want to remind you, that is the derivative of the first derivative. The derivative of this part over here is positive because the slope is increasing. Between B and E, the slope is negative, so it's concave down there. And greater than E, it is back to concave up again because the slope is positive. So is it concave up between negative infinity to B and from E to infinity? Let's see here. It's concave up between negative infinity to B, and that's true, and between E and infinity, that's true. Wow, I picked a guy right from the beginning that I think A is my answer. But we better check it out. Let's check the other guys, and let's see what's wrong with them. F is increasing on the interval between A and C. Well, that's true. It's above the x-axis. And F is greater than infinity. That's true. It is concave up between D and infinity. Well, concavity deals with the derivative of the second derivative. Notice the derivative is down, starting at E, and it goes down to E, and then it goes back up again. So it's concave down this part and up that part. That part, the second part right here about being concave up, it's false. So B is off. F is increasing when between negative infinity to B. Between negative infinity to B, it's increasing. Well, no, that the slope of that line is increased. That means it's concave up. That's false right there. It's not increasing. Remember, this is the graph of the derivative. So for the derivative to increase, the function had to be, or for the function to increase, the derivative has to be above the x-axis. So this part right here is false. So I'll forget the rest of it. Is F increasing from negative infinity to B? No, negative infinity to a B, it is concave up there because the slope is positive, but it's not increasing there. So that's false. F is increasing from negative infinity to B. That seems to be the common thing here. For all those are false. So which one is my answer? Like we thought, A. Let's take a look at number 6. What is number 6? This goes back to chapter 1 and the end of chapter 1 and the beginning of chapter 2. Knowing the definition of derivative. You know they're going to hit you hard on this one. At least a couple of questions on the old exam. What is the definition of derivative? Well, f prime of x is equal to the basic definition was that limit as h approaches 0 of f of x plus h minus f of x all over h. other definitions that you need to know. F prime of x is also equal to the limit as delta x approaches 0 of f of x plus delta x minus f of x all over delta x. It's the same thing. I replace h with delta x. But there was this other one, but this is the derivative at a point. At a is the limit as x approaches a of f of x minus f of a over x minus a. That is the definition derivative at a point. This are your derivative of a function. This is at a point. Okay? The other one that's at a point is this one. F of a is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. These are all the definition of derivatives. These last two are derivatives at points. These first two are derivatives at a function. They want to know which one is the derivative of a function here. So here we go. Straight up. The derivative is going to be equal to the limit as h approaches 0 of f of x plus h. F of x plus h would be the cosine of 3 times. Wherever there's an x, plug in an x plus h plus 1 minus f of x, just copy the function down, which is a cosine of 3x plus 1 all over h. Okay? And the only thing you could do to clean this guy up is you could have distributed. This would have been 3x plus 3h plus 1. So which one of these guys is going to be my answer? 3x plus 3h. They forgot to distribute the 3 there, so that one's wrong. 3x plus 3h plus 1. That's a 3. No. 3x plus 3h plus 1 minus cosine 3x plus 1 over h. Yep. Answer C. Matches up to this, but it cleaned up a little bit in my parentheses. But notice, you were expected to know the definition of derivative. Take a look at the next guy, number 7. The derivative of a function g of x is given by g prime of x is equal to negative 7 times x plus 3 squared times x minus 1 times x minus 5. This is your derivative. They've given it to you. The question is this. Find the x coordinates, only x, you don't need to know what the g function is, for local maximums and the local minimums. Which one is going to be maxes, which one is going to be mins? We had a problem like this on your last test, which I will give back to you guys tomorrow. Here's the deal. They've given you the derivative. You've got to find critical numbers. How do you find a critical number? You take derivative and set it equal to 0. Then you set each factor that has an x in it equal to 0. So there's an x plus 3 squared. That's a factor. Set it equal to 0. X minus 1 equal to 0. X minus 5 equal to 0. Take the square root of both sides and solve for x. I got negative 3. I got 1. And I got 5. Okay? Take each factor. They went ahead and gave you the derivative, and they went ahead and factored for you. Negative 7 doesn't matter. It's just a constant. Set each factor equal to 0. Now, draw a number line. Draw a number line. And put your numbers in order. The smallest critical number is negative 3. The next one is 1. The next one is 5. Now, this is your intervals of increase and decrease, which means I got to do test values into my derivative. So I'm going to pick a number between negative infinity to negative 3. I choose negative 4. And I'm going to plug it into my derivative. I'm going to pick a number between negative 3 and 1. And remember, I have a brain, so I choose, good choice, 0. Between 1 and 5, I choose, this is G, G prime at 2. And something bigger than 5, I guess I choose 6. And these are the numbers I'm going to plug into my derivative. By this time, I have a calculator. And I showed you guys some tricks on that. In terms of quick plotting, I'm going to type in my derivative under y equals. And this is coefficient, every part of it. Negative 7 times parentheses x plus 3 squared times x minus 1 times x plus 5. I'm sorry, x minus 5. Make sure you type it in right. X minus 5, close parentheses. And double check it. Just watch the careless errors. There we go, there we go, there we go. And I'm just going to hit zoom 6 on it. I'm just going to graph it. Don't care. Because what I'm trying to do is I'm trying to plug into this thing test values. So I'm going to second calculate value. I'm going to plug in -4. What number do I get? -315. I don't care. It's negative. So everything in that interval is going to be negative. Plug in 0. I get -315. I got some more negatives. Plug in 2. I get 525. That's positive. And I plug in 6. I got -2,835. Don't care, it's negative. Don't care what the numbers are, it's negative. What is this going to tell me? This is going to tell me that my function decreases between -infinity and -3. It decreases between -3 and 1. It increases from 1 to 5. And it decreases from 5 to infinity. So let's take a look at these critical points and decide what they are. -1 because positive 1. Because I go down and go back up, what's happening at +1? Go down and going back up, it is a minimum. So at x equals 1, we got a minimum. Now I'm going up and coming back down. What does that make my critical number 5? Maximum. So x equals 5 is a maximum. What about -3? I go down, hit my point, and go down some more. It makes it not a max min. Okay, it's still a critical point, but it's not a max min. To be a maximum or minimum, you have to change increase and decrease. Does that make sense? You've got to increase then decrease or decrease then increase. So -3 is nothing. Don't need that guy. He's probably an inflection point. So, that being the case, what's my answer here? Minimum at x is 1, maximum at x is 5. Minimum at x is 1, maximum at x is 5. Okay, hold on. Make sure you get it right. So that one they seem to have backwards because this is what they do to you. Maximum at x is 5, minimum at x is 1. Okay, fine. What's my answer? Answer is D. Be careful in picking your answers. Yes, sir.
I just wanted to share something quick. I had an issue yesterday when I was doing the test with my calculator.
Yeah.
Using that trick, and my calculator was giving me all kinds of funky things, and then it turned out that I guess what I was using previously, I had stored the value in the x variable.
You have a TI-89?
Yeah.
Okay. That's different. I was using the TI-84, which is x's are local variables. So every time you just use x, it graphs it, and now I go move something else, x will change. If you have a TI-89, never store anything under the x, y, z, or t variables. Those are called global variables on a TI-89, and they're used all the time. So once you store it as something or other, it changes it from being a variable to being a constant. So when you graph or do anything, it doesn't do anything because it sees x as 5, and so plugging in 5 into this function gives you a constant. So everything's a constant. And so, if you still have a problem with that, let me know, and I can basically go in and delete under your memory the x as a constant term and create it back as a global variable again. That's a technique on a T89. Okay. All right. Number 8. A particle moves along the x-axis with position time is given by x at t equals 400t minus t cubed. Between 0 is less than or equal to t, where t is measured in seconds, x in feet. What is the average velocity between 5 and 10? What is average velocity? Another formula. So when you do these exams, this is why you want to do multiple exams, not just one. Because every time they throw a problem like that, it reminds me, oh yeah, there's another formula I need to have memorized. To get average velocity, that's equal to the function at time 2 minus the function at time 1 over time 2 minus time 1. And this function is your distance function. Okay? So this is your distance. I'm just writing down the formula for you guys. This is your distance function. So in my case, it would be x at, we're going from 5 to 10, so it would be x at 10 minus x at 5 over 10 minus 5, because they gave me the position. Average velocity doesn't use derivatives. Instantaneous velocity, that's when you use the derivatives. Know your terminology. So, x of 10. So I'm going to plug in 10 into this thing. Well, I'll go to the home screen here. Plugging in 10, 400 times 10 minus 10 cubed is 3,000. So this is equal to 3,000 minus, when I plug in 5, 400 times 5 minus 5 cubed, plugging in 5 for t here, I got 1875 divided by 10 minus 5. 3,000 minus 1875 is 1125. Divided by 10 minus 5 is 5. So divided by 5 is 225. And it is a velocity. And distance is measured in feet. Time is measured in seconds. So I got 225 feet per second. The answer is clearly B. Does that make sense? But to me, this was an easy problem. But what made it so easy? I memorized the formula. With average velocity, I knew what to plug it into. Part 9. As in problem number 8, the particle moves along the x-axis given by position x at t equals 400t minus t cubed for x 0 is less than or equal to t, where t is measured in second each frame. What is the instantaneous velocity? There's your buzzword right there. Instantaneous velocity. To get the velocity formula, instantaneous velocity, that's the guy you got to take derivative of. Take derivative of your distance function. Derivative of 400t is 400. Minus derivative of t cubed is 3t squared. Time is 7.5. You notice our professor loves decimals on this thing, so that's okay. But at this point, we actually have a calculator. So the velocity at 7.5 is I'm going to plug in 7.5 in for t. So there we go. This would be equal to 400 minus 3 times 7.5 squared. 231.25. It's the velocity, so it's feet per second based upon the units they gave me. 231.5 is which one? Oh, 25. I said it, I wrote it down, and then I read it wrong. 231.25 feet per second, and the answer is C. There you go. Again, in my mind, 10-second questions. But then, of course, I throw this one at you. All right. Find the maximum area of the rectangle inside of a triangle formed by the x-axis and the lines y equals negative 3 plus 12 and y equals negative 3x plus 12 and y equals positive 3x plus 12. If the base of the rectangle is on the x-axis and the upper two vertices are on the lines y equals negative x plus 12 and y equals 3x, negative 3x plus 12 and y equals 3x plus 12, as illustrated. This problem right here, I saw students just have that same look that you guys have. What? Look, you know that look? What am I supposed to do? First thing you're supposed to do is draw the x-axis. You've done this problem in class before. I just made it. I did parabolas and circles. This one, dude wanted a triangle. Who cares? Where is your axis at? I'll put it on black ink here. Where's your axis at? Right here. Here's your x-axis. Here's your y-axis. The trick to this problem was labeling it. This is the line. But which line is this guy? It's a line, but make sure you put them in the right spot. It's important. This is a line. But the slope is going down. So I only got two lines. It's either y equals negative 3x plus 12 or y equals positive 3x plus 12. Which line is this dude? Negative, because the slope is going down. This is the line y equals negative 3x plus 12. This is the line, which you really don't need, is y equals positive 3x plus 12. Okay? And we want to maximize what? Maximize area of what? Rectangle. There's a rectangle right in here. But because, here's the trick, because you put this guy on the x-axis, this is an x point, this will be a negative x point. When you go up, this is a y point, so this is a point x, y. You go over x, up y. Does that make sense? And that makes the point x, y. This is the point negative x, y, but you really don't need him. Let me explain why. Okay? This is a maximized Binocq-wise equation. Let's go through our steps. Step number 1, read problem, draw a picture, and label it. They needed to be labeled. Step 2, come up with the objective equation. Our objective is to maximize the area of the rectangle. Okay? What is the area of the rectangle? Okay, we're talking about this area right in here. Based upon the units and the variables that I put, it's a rectangle. Area is length times width, but I got to use my variables. What is the length of this thing? How long is that part right there? It is 2x, because it's x there and an x on that side makes it a 2x. Times the height. What's the height of this thing? Times y. The area is 2x times y. Classic. Maximize, minimize problem. Take derivative, set equals 0, and solve. I got a problem. My problem is too many variables. So what am I going to do? Well, I got to do a constraint equation. Well, I'm going to use this side because I like the positive side because I'm using positive x here. That negative x, I just made him 2x because it's a reflection here. So I'm going to use this as my constraint because that's the side in the positive first quadrant. He's the better guy to use. You could use the other guy, but be careful when you get some kind of negative answer. It's okay. Just change it to positive. You get the right answer here. But I'm going to use this guy because I like stuff in the first quadrant. Because the first quadrant, everybody's positive. Does that make sense? So my constraint is y equals negative 3x plus 12. So I'm going to plug that in right in here. So area would be equal to 2x times negative 3x plus 12. Let's clean them up. Area equals negative 6x squared plus 24x. Agreed? How do you maximize or minimize anybody? I finally got my objective equation in terms of one variable. What am I going to do now? Here's the payoff. It's calculus. What are we going to do? Take the derivative, set it equals 0, and solve. What's the derivative of negative 6x squared plus 24x? Negative what? 12x plus 24. Set it equal to 0 and solve. I'm going to move my 12x to the other side. That gives me 24 equals 12x. Divided by 12, x is equal to 2. Does that make sense? But be careful. Never forget my steps. Step 1, objective equation. Step 2, step 1, read problem, draw a picture. Step 2, come up with the objective equation. Step 3, come up with the constraint equation. Well, they gave us that. Step 4, solve with the constraint equation for one variable, plug it into the objective equation, and clean them up. Step 5, take derivative of the objective equation, set it equal to 0 and solve, but never forget step 6. What was step 6? Go back and read the problem to figure out what they want me to do with this. Answer x equals 2. That may not be the answer they want. What am I supposed to find here? Find the maximum area. They wanted me to find the area. X is 2. And notice it's positive because I used the line that was in the first quadrant. Over here, I would have gotten the answer, x equals negative 2. But they want me to find the area. Well, remember, area was equal to this equation, negative 6x squared plus 24x. You with me? But what's x equal to? 2. So go back and plug it in. Area would be equal to negative 6 times 2 squared plus 24 times 2. Well, let's see here. I think I get 24 in my head, but let's just double check on the calculator. Negative 6 times 2 squared plus 24 times 2. I got 24. And the answer would be 24. It's area, so it's units squared for those people who love, showing all your work and your details in case this was a free response question. But the answer is B, 24. Does that make sense? But a lot of students skipped over this problem thinking they were going to come back to it. And when you skip over a problem, be careful because they tend to forget to go back to it and they leave a problem blank and there's no way to get those kind of problems right. Yes, ma'am. You're going to have to speak up a little bit, sir, because I'm way up here. Sure. You would have gotten x equals negative 2 because you put in the equation 3x plus 12 instead of negative 3x plus 12. And that's what I was just mentioning. If you put in the equation y equals positive 3x plus 12, that's the line in the second quadrant. In the second quadrant, your x's will be negative. So you get the same number, negative 2, but when you plug it in, you get the same area. So you could have used either equation. I chose to use the equation of the line in the first quadrant because that does give me all positive answers when I solve for x equals 2. But you do right. You get the same answer. All right. Here's a college algebra question. Only they just gave us really bad-looking graphs here. Here's the deal. This was not a calculus question. This was a kind of from your chapter review, chapter 1 question stuff here. Find the graph of the first graph on the left below is the graph of y equals f of x. Here's my function right here. Which of the graphs labeled A, B, C, D, or E represents the graph of y equals negative f of x plus 1? All right, let's go through this. I'm trying to analyze this guy up here. Y equals negative f of x plus 1. This is something we called in college algebra pre-calculus techniques of shifting, stretching, and reflecting. When I work inside the parentheses, that's a horizontal shift. Inside my parentheses is x plus 1. But this horizontal shift has an opposite effect here. I see a plus 1 inside my parentheses. That's a horizontal shift, but which way will I take him? Left 1 unit. And then order of operations, what comes next is multiplication. Multiplying out front, this is that stretch reflect when you take multiply a number times a function. And what is a negative going to do for me? It is going to reflect about x-axis. Now, this question is more of a mental question than anything. You have to visualize. Take this graph, shift him left 1 unit, then reflect him across the x-axis, aka flip him upside down. So left 1 across the x-axis. If I go left 1, it'll be this way. When I flip him across the x-axis, he'll be down here going through like this. So which one of these graphs is it? Left 1 flipped upside down. Which one's flipped upside down? There's only 2 of them have this thing flipped upside down. So I got a 50-50 shot now. Is it answer D or is it answer E? Which one was shifted left before it was flipped? You got it. The answer is E. Did that make sense? Again, in my mind, analyze your pictures, but not a very tough question. It's a chapter 1 review style question, a college algebra review. It wasn't a calculus question. But this is what you needed to know. Does that make sense? All right, number 12. The second derivative of f of x is given by 16x minus x cubed. Find the x coordinate of the inflection point of the function. All right? They want us to find an inflection point. How do you find an inflection point? Definition stuff here. What do? You take the second derivative, you set it equal to 0, and you solve. But an inflection point, by definition, understand this. Make sure you understand. An inflection point is where you change concavity. Going from concave up to concave down, or vice versa, going from concave down to concave up. You have to change concavity. All right? So, but how you find them is you take the second derivative, which they gave us, 16x minus x cubed. There's my second derivative. I'm going to set it equal to 0 and solve. I'm going to factor out an x out of the thing. That's going to give me 16 minus x squared equals 0. I'm going to factor that guy because that's a difference of squares. That's 4 minus x times 4 plus x equals 0. I'm going to set each factor that has an x in it equal to 0, and I'm going to solve this thing. I get x equals negative 4. I get x equals 4. I get x equals 0. I have 3 different inflection points, but be careful. They're trying to mess you up with that. That definition I said. An inflection point is where you change concavity. I got to check it out. So, for concavity, I'm going to find my intervals of increase and decrease. So I'm going to draw a number line and analyze it. So, in order, here's negative 4, here's 0, and here's 4. I'm going to use some test values, but I'm doing for concavity, so I'm going to go for a second derivative. So I'm going to plug in a number less than negative 4, I choose negative 5. Between negative 4 and 0, I choose negative 1. Between 0 and 4, I choose positive 1. And bigger than 4, I choose 5. I'm going to plug these numbers into my second derivative. So I'm going to plug it over here. Y equals, clear out the old graph. That'll be 16x. There's my second derivative, 16x minus x cubed. Maybe you guys can see it better if I do that. All right. And then I'm going to just graph it. And I'm going to evaluate these guys at these points. Second, calculate value, negative 5, I get 45. That's positive. That means it is concave up in that region. When I plug in -1, I get -15. It's negative, which means it's concave down in that region, which means I change concavity, which makes -4 an inflection point. When I plug in 1, I get positive 15. It's positive, so which means I'm back to concave up. I'm going from concave down to concave up, which means 0 is an inflection point. And when I plug in 5, I get -45. So it's negative, means it's concave down. I'm going from concave up to concave down, which means that's an inflection point. So what's the answer on this one? D. There are 3 inflection points, -4, 0, and 4. But I had to check it out. If they did this, if it was positive, -4, and then some more positive stuff, the -4 would not be an inflection point because you didn't change concavity. Does that make sense? Look for them to do that to you guys tomorrow. And now, we're on to the third and last section of the test. To give you guys some hints, number 1, you guys are in my class. First things first, you know something about every problem. Don't leave anything blank. We do grade on partial credit, so do write down something, even if you mess it up or something or other. At least write down everything that you know about a particular problem, so in case you can pick up 1 or 2 points here, there, everywhere, it's going to add up. Don't leave anything blank. I've never seen this problem before, I don't know how to do it, and just walk away. Don't walk away. Write down something, try it out. What we like to do is give you guys problems that make you guys think about stuff. Okay? Let's take a look at this first guy. And the second thing is this. You guys are in my class, and Liz's classes for that matter too. Don't make stupid comments on the exam. Now granted, we got a committee grading this stuff, and I do enjoy reading other students' comments because they're stupid, but it's kind of funny to me watching, this is a stupid exam, I don't know why I had to do it. You know, questions like that, or they'll make some weird comments about the guy who made up the exam or where they got these kind of questions from. That's fine for other students, not my students. My students are above board. Do the exam, do your best, never leave anything blank, show all your work. This is their grading on not just the correct answer, but the procedure of how you got the correct answer. Show your work. You will actually, there are certain problems on here, if you just put the right answer down in the blank, you may not get full credit for it because you didn't show your work on how you got this answer. You have to show your work. Here we go. Answer the following questions below on finding on the following information about y. Justify your answers. Number 1, the function is continuous and differentiable. That means it's smooth and continuous. I don't have any problems with vertical asymptotes or anything like that, or any kind of cusp or anything. Second thing, f of x is less than 0 for x is less than 0, and f of x is greater than 0 for x's that are greater than 0, which tells me this. When I'm doing this stuff, I kind of want a clue. So I'm going to draw myself a little axis, and this is a general shape graph, but this should be able to answer any kind of questions they have. This is the work. All right. The function is less than 0. That means you're below the x-axis for x is less than 0. So here's 0. I know my function is down here someplace. And the function is greater than 0 for 0 less than x, for the same thing as x is greater than 0. So I know my graph's got to go this. So I know my graph has got to be in the third quadrant and the first quadrant based upon that first information. The second information. I know it's continuous and smooth, differentiable. But now let's talk about the derivative. That's your slope of your tangent line. Between -6 and -2. All right, I got to put some hash marks here. 1, 2, 3, 4, 5, 6. Here's -6 and here's -2. There may be some more points out of there. And 1, 2, 3, 4, 5. Between -6 and -2, what is my slope of my tangent lines? Less than 0, which means it's negative. So between -6 and -2, I know my slopes are going to have to go down here. So in between these two guys, my sloping is going to have to go down. Don't worry, I'm going to put up an elaborate graph. I'm just trying to interpret their stuff. And bigger than 5, x is greater than 5, I know I'm going to have slopes that are negative. But I know in the first quadrant, my graph is up here, so I know it's got to go down in between these two guys. I'll put some curvature to it, so this is why I'm drawing it in pencil. Number 4. So I know I got graph down here and over here. Number 4, the derivative for x is less than -6 is greater than 0. So over here, -6, I got to be positive slope here. And between 2 and 5. Between 2 and 5, between -2 and 5. Between -2 and +5. -2 is down, it's got to be down here. So I've got to have positive sloping up here, and I got to have positive sloping this way. Okay? So I'm already identifying -6 is going to be a maximum, -2 is going to be a minimum, looks like 5 is going to be a maximum there. Alright, so we keep going. Let's talk about concavity now. F double prime of x is less than 0. It means it's concave down between less than -4. So here's -4 right here. So I know I've got to have my concavity like this. Okay? Up to -4. Let me stop there for a second. Okay? And then 3 to 7, I've got to be concave down. 3, 1, 2, 3 to 7, 5, 6, 7. Here's 7. Between 3 and 7, I've got to be concave down in this interval too. Okay? And then what? I'm concave up between -4 and 3. -4 and 3, and I got to go through this stuff here, so I got to be concave up. Right here, this is inflection point, concave up. Again, I'm drawing general shape graphs here. All right? And then from this, and bigger than 7, I got to be concave up. Here's 7, concave up. So out of all my information, this is basically what I got from my graph. I'm going to go down here. Here is 6. There's a point. I can start putting pen again. Point here. This 4 is an inflection point. -2 is where I changed increasing to decreasing. So -2. It's not the greatest graph in the world here, but I got to go down here. So -2 down here is going to be a minimum. Here's a minimum. This is going to be a maximum. And then at 3, I'm changing concavity. This is concave up to concave down. And this at 5, was it at 5? Yeah, at 5, I have a maximum. But now, I've basically got a general shape graph. This is just being not very elaborate, but this is really showing my work. Now, here's the deal. On which intervals is the function decreasing? To decrease is where the derivative, first derivative is less than 0. Where are we decreasing at? First derivative is less than 0. Between -6 to -2. Between -6 to -2. Where else am I decreasing? From -6 to -2. And I'm decreasing, I made a typo here. I'm decreasing -5 here, so this thing's got to continue to do this. Keep going down here. There's more of a better picture of my graph here. All right, but I'm decreasing from, and I go back to my first derivative, x is greater than 5. Union 5 to infinity. And I'm using my picture with this information up here to get my answers. What x-coordinate is a local maximum? Where am I having my maximums? I believe I found 2 maximums based upon my graph. What was the x-coordinate? X equals -6. Right here. And what else? X equals 5. And it's based upon my picture because that's where the critical points are. 5 and 6. And also -2, but -2 ended up being a minimum. On what intervals is the function concave up? To be concave up, the second derivative has got to be greater than 0. Where's my second derivative greater than 0? I can read it right off here, but I can also look at my picture. That is between -4 and 3 union 7 to infinity. And so, again, reading it right off the equation there. But this really showed my work. And then what is the x-coordinate of the inflection points? What inflection points? Where did I change concavity? -4. And where else? This was concave up to concave down. Where else? 3. And where's there another one? Where am I changing concavity at? Negative 4, 3, and you got it. X equals 7. Over here, 7. I went from concave down to concave up. 3 points. Again, they didn't ask me to graph it, which was nice, but there's my work right there, because you really need to see what the graph looks like to help you figure out max mins and stuff, putting all the pictures together. Yeah? Where is it decreasing at? Oh, at 3, you're still increasing over here. It's starting at 5, because 5, look at your critical points. Max, mins, increase, decrease. Start with your critical points. Your critical points where you change is negative 6, 2, and 5. That's where you're changing, going from increasing to decreasing. That's why. Okay? Here's a web work problem for you. Number 2. Use the following table for A, B, and C below. And usually each one of these things are worth 10 points apiece. They'll give like something like this. This one will be worth 4 points, 3 points, and 3 points, or something like that. But this is web work, using tables to take derivative. This is where they stole this one from. All right, you want to find B prime of 4. They gave you B of x is g of x over f of x. So if you want to take derivative first, what rule are you going to have to use? Quotient rule. Derivative the top times the bottom minus the top times derivative the bottom all over the bottom squared. Does that make sense? Now we want to find B prime of 4. So what I'm going to do here is plug in 4 into this thing. This will be g prime of 4 times f of 4 minus g of 4 times f prime of 4 all over f of 4 quantity squared. And then from this point on, I now use my chart to plug in numbers. What's g prime of 4? G prime of 4 is negative 8. F of 4, there's f of 4 is 2, minus g of 4 is 3, times f prime of 4 is 10, all over f of 4, which is, so f of 4, which is 2, squared. This is the work they wanted to see. Now, at this point, just to make sure I don't screw it up, because on the free response you're allowed to have calculators here, this will be parentheses right in the numerator. Negative 8 times 2 minus 3 times 10 divided by 2 squared. I got the answer a negative 11.5. Does that make sense? Don't lose you guys anywhere. And this is what the answer was, and this is what they're looking for. But as well as the answer, they're looking for how did you get this answer. What about this guy? You're supposed to find h prime of 3. H prime of x is g of f of x. What rule do you have to use to take derivative of this guy? G of f of x. G's on the outside, f of x is on the inside. What do you call it? Chain rule. So take derivative, chain rule. Take derivative of the outside, inside stays the same times derivative of the inside. They're trying to work to make sure you know these rules. Derivative of the outside, g prime. The inside, f of x stays the same, times derivative of the inside. Does that make sense? Now, we're supposed to find h prime of 3. That'll be g prime of f of 3 times f prime of 3. This will be g prime of, what's f of 3? F of 3 is 1 times f prime of 3. What's g prime of 1? G prime of 1 is negative 3. What is f prime of 3? F prime of 3 is 13. What is negative 3 times 13? Negative 39. And there's my answer. Does that make sense? All right. Take a look at the next one. 8k prime of 2 given k of x is equal to f of x quantity cubed. All right. So here we go. What am I going to do here? Well, k prime of x. I see f of x on the inside, cube on the outside. So what rule am I going to use? Chain rule. Derivative of the outside, the inside stays the same, squared, don't forget your power, times derivative of the inside. Does that make sense? But what do they want me to find? K prime of 2. That'll be 3 times f of 2 squared times f prime of 2. This is 3 times, what's f of 2? Go to my chart. There's f, there's 2. F of 2 is 4 squared times, what's f prime of 2? F prime of 2 is equal to 7. So literal substitution, this is where the chart comes in handy at. And now this is going to give me 16 times 3 times 7. That's definitely a calculator problem. 3 times 4 squared times 7 is 336. And there's my answer. But it's not just about getting the correct answer. It's about showing the work at how you got the correct answer. They want to see all this stuff. Does this make sense? Is this difficult? All right, let's go to problem number 3 then. Find the absolute maximum and absolute minimum values of this function f of x equals 2x cubed minus 150x squared plus 50,000 on each interval. All right. How do you find absolute maxes and mins? First thing you've got to find is critical numbers. How do I find a critical number? First thing I'm going to do here is take the derivative, set it equal to 0, and solve. So 2x cubed, derivative of that would be 6x squared minus 150x squared is 300x, and derivative of 1500 is 0. Set it equal to 0 and solve. I can factor out a 6x. That leaves me with x minus, and when I take a 6 out of a 300, 300 divided by a 6 should be 50. So that'll be minus 50 equals 0. Set each factor equal to 0. 6x equals 0. X minus 50 equals 0. I get x equals 0. X equals 50. These are my pretty much CNs, critical numbers. What do you remember about finding absolute maxes and absolute mins? You've got to compare CPs compared to EPs. This time they gave me the interval between negative 20 and positive 20. My endpoints are negative 20 and positive 20. The critical points are what? 0. The CNs are x equals 0, x equals 50. But look at your interval. You only care about numbers within your interval. 50 is outside my interval. Blow him off. You're only allowed to look at numbers, critical numbers, that are inside your interval. You don't care what's happening at 50 because you only care about what's between negative 20 and 20. And this is the real question they're asking you guys. So many students try to put 50, there's your maximum. No, it's not, because it's not even in the interval. And a lot of students screwed that up because they weren't paying attention to what the interval was. There's only one critical number in this one, it's 0. How do I get y coordinates? What do I have to do? Plug it into the original equation. So I want f of 0, which is 2 times 0 cubed minus 150 times 0 plus 50,000, gives me 50,000. That's 50,000. I got to find f of negative 20. That's 2 times negative 20 cubed minus 150 times negative 20 squared plus 50,000. And I got to find f of positive 20. That's 2 times 20 cubed minus 150 times 20 squared plus 50,000. Let's see what we get here. So, plugging it in, 2 times negative 20 cubed minus 150 times negative 20 plus 50,000. Oh, thank you. Be careful, I'm trying to rush here. Square. There you go. Take your time. Make sure you type it in square. There you go. I got this. I got negative 26,000. And when I plug in positive 20, making sure I got my right equation, I just call it back down and delete all the negatives out of this thing. And I get 6,000. And what I'm doing here is this. I'm showing them my work on how I got these y coordinates. Showing work is everything. Be more elaborate on the free response than you are on the multiple choice stuff. Negative 20, what did I get? Negative 26,000. And at 20, I got 6,000. Does that make sense? And how do I figure out which one is the absolute max, absolute min? You look at the y-coordinates. So the point 0, 50 is the absolute max in this interval, and the point negative 20, negative 26,000 is the absolute min. But never forget to tell them this. Go back and read the question. Find the absolute minimum and absolute maximum values of the function. And I kind of hit you guys hard on this even on my test. When I ask for the values, when these people that make up these exams ask for the values of a function, what are you going to give them? The y-coordinates. It occurs at the x-coordinates. The values of the y-coordinates. So the maximum value, so in this problem, answering their question, the absolute max value is equal to what? 50,000. And the absolute min value is equal to negative 26,000. Does that make sense? This is what we wanted to see. Every detailed part. Questions? Now, look at this guy. They changed my intervals. Well, now, remember I had CNs. I don't have to redo this stuff. This is still part of my work. I had a critical numbers at 0 and x equals 50, but now notice that both 0 and 50 are inside my interval. Does that make sense? So now I'm going to go for the CPs, 0, 50, and then I got to go for the EPs, endpoints. My endpoints on this thing is negative 10 and 60. You with me? I've already done 0. When I plugged in 0, I got 50,000. But the rest of them I'm going to have to plug in. So here we go. F of 50 would be 2 times 50 cubed minus 150 times 50 squared plus 50,000. We'll crunch him out in a second. F of negative 10 is 2 times negative 10 cubed minus 150 times negative 10 squared plus 50,000. We'll crunch him out in a second. And F of 60 is 2 times 60 cubed minus 150 times 60 squared plus 50,000. Okay? So I'm going to go plug these in on my calculator again. When I plug in 50, I got negative 75,000. When I plug in negative 10, double check me on this, I got 33,000. And when I plug in 60, I got negative 58,000. Double check me, but you're right. This is all calculator work. So at 50, when I plugged in 50, I get negative 75,000. When I plug in negative 10, I got 33,000. When I plug in 60, I get negative 58,000. Well, who is your absolute max? Who is the absolute min? Who's the biggest number around? 50,000. So the absolute max is 50,000. What's the absolute min? Which one? Oh, at 50. It is the absolute min is the negative 75,000. You're comparing y-coordinates. So again, to answer your questions, the absolute max value, the maximum value again was 50,000, but the absolute min value was negative 75,000. Does that make sense? Now, here's the deal. A lot of folks lost a ton of points on this stuff because they just did box that answer and box that answer. Because you know what they did? They just went up here and graphed the old equation here. 2x cubed minus 150x squared plus 50,000. Right? And they just went the window between negative 20 and 20, and they did zoom 0 on the calculator. and they look at the graph, and they decided, all right, well, there's the maximum because that's the tallest point around. Right there is your minimum, and they found the values of those points. Awesome. But what work did they show? All they did was write down the answers. Some of them drew a graph. They gave them a couple points for that, saying there's some signs of intelligence, so they gave them a point for that. But did you use calculus? Did you take a derivative, set it equals 0, and solve any of that using the calculator? No. Show your work is what they're after. All right. A couple more here, and then we're done. Here's a classic one. All right. A large rectangular area is to be fenced off as in the diagram below. The large rectangle divided into two smaller rectangles. The fence used to divide the spaces costs $10 a foot. All right, so what we got here is to divide the spaces costs $10 a foot, and the fence used for the perimeter costs $15 a foot. So you got to outthink the problem, because now we got to put some numbers and math into this one. The outside is $15 per foot. The one that subdivides the space right down here is going to cost me $10. $10 per foot. Per foot there. $10 per foot versus $15 a foot. Does that make sense? Okay. The total budget for the project, so I got a budget for the project is $60,000. Okay. We want dimensions that does what? Largest area. So what are we supposed to do? We're going to maximize area. Step one. This is a optimization problem. Step one. Read problem, draw a picture, and label it. I'm going to label this X. This is X distance. X. This will be X. This will be X. I'm going to label this distance Y. So this is Y and this is Y. So we want to maximize area. Step one. Read problem, draw a picture, label it. Step two. Come up with the objective equation. We want to maximize area. Therefore, my objective equation is come up with the area equation where I can take derivative, set equals 0, and solve. What is the area of my rectangle? Length times width will be X times Y. There's your objective equation. Next thing you got to do is come up with the constraint equation. What's the constraint equation? A constraint equation, equation that uses the given information. What was given? We were given a budget. And here's where the math comes in at. All right, here's my budget. The budget is $60,000 to put the fence. Where are we putting fences at? We're going to put it here and here, X, X, and this X in the middle, and here Y and Y. And I wrote them all out. 3 X's and 2 Y's. X, 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 Y, and Y. But here's the deal. There's a budget, so we've got to put our numbers, our cost in it. How much is this X going to cost me? That'll be that first X. What is that going to cost me? That's $15 a foot, so that'll be 15X. 15 times however many feet I have. Does that make sense? Plus, this is the middle X right here. How much is that middle X, that fence right down the middle of my property, going to cost me? That only cost me $10 per foot. So that's a special fence there. And then this third X over here is back to on the outside, because I need some more borders, is going to cost me another $15 a foot. And what about the Y's? This Y and this Y. Both of them are on the outside, so what are they going to cost? $15 a piece per foot. $15 per foot. Does that make sense? You see how I kind of drew this out? So it's a 15Xer, 10Xer, 15Xer, 15 wire, and a 15 wire. So my constraint is this. 60,000 is equal to 15, 10, and 15. 15 and 15 is 30, plus 10 is 40. So that's 40X, plus 15 and 15 is 30Y. There's my constraint equation, putting the cost per fencing into the equation. Does that make sense? Did I lose you guys anywhere? All right? Now, next step on optimization. What are you going to do? I'm going to solve the constraint equation in terms of one variable. This would give me Y is equal to, let's see here, 60,000 minus 40X divided by 30. I subtracted 40X and divided by 30. I solved for Y. But you really want to clean this guy up. Since you divide by a single denominator, you can take each one. So I can take the 60,000 and divide by 30, which would give me 2,000 minus 40 divided by 30 is the same thing as 4/3 x. It's best to go and clean up your algebra first before we start doing our calculus. John's fundamental rule of calculus. Does that make sense? All I did was take my 30 and divide in each term. I'm going to take this guy and plug him in for y. This is going to give me area is equal to x times 2,000 minus 4/3 x. Clean them up. Area equals 2,000x minus 4/3 x squared. Now, there's my objective equation. It's in terms of one variable. How do I optimize? Take derivative, set it equals 0, and solve. So what's the derivative of 2,000x? 2,000. Minus, what's the derivative of 4/3 x squared? Well, derivative of x squared is 2x. Bring down the 2. 2 times 4 is 8. That becomes 8/3 x. Set it equal to 0 and solve. I'm going to move my 8/3 to the other side. 2,000 is equal to 8/3 x. I'm going to multiply by 3 on both sides. 3 times 2,000 is 6,000 equals 8x. And then I'm going to divide by 8. And this gives me x is equal to, let's see here, 6,000 divided by 8 is 750. Are we done? Lord, no. Last step. Step number 6 is go back and read the problem and make sure you answer their question. I know I should make x 750, what's my units on this thing? Feet. So everything's cost per foot there. So here we go. What was the question? What are the dimensions that yield the largest area? The question is about dimensions. What is the dimensions of this thing? The dimensions are x by y. We figured out what x is. What's x? 750 what? Don't forget your units. It was worth points. This thing was measured in feet. How do I figure out what y is? Go back to the constraint. That's 2,000 minus 4/3 x. But what's x equal to? 750. So back to the calculator again. Y equals 2,000 minus parentheses 4/3 times 750. 1,000. So my dimensions are, this plot of land is going to be 750 by 1,000 feet. 750 feet by 1,000 feet. And there is my answer. Does that make sense? And then that's all they asked for was find the dimensions. They didn't ask for what was the total area or anything like that. Just go back and make sure and box in their answers. Helps out the graders if they're doing this stuff. Does that make sense? Did I lose you guys anywhere? All right. Well, we still got, I don't know, hour and a half more of this exam, but we only got one more question. Let's take a look at it. This next question was the one that messed a lot of people up. A lot of people lost some points on this one because they didn't know what to do. And all I could tell them was, web work. All right. The reason why it wasn't exactly like the web work problem. And it was that related rate. You remember the old 6-foot-tall woman problem with the light post? Well, it's kind of like that. And they even tried to make reference to it. They used the same 6-foot-tall woman. All right, a spotlight on ground level. They put the light at a different spot. That's what messed people up. A spotlight at ground level is located 40 feet away from a very tall building. Directly in front of the door into the building, a 6-foot-tall woman exits the building and walks directly towards the light. If she walks at 5 feet per second, how fast is the length of her shadow on the building changing when she is 10 feet from the building? It's a related rate problem. And you'll be amazed how many people screwed this problem up or just left it blank. I mean, you can't afford to leave a 10-point problem blank on a final exam that is worth more than 30% of your grade. So, you know something? What's the first thing you should do? Draw pictures. Get an idea of what's going down. Label everything. All right, so what do we got? We've got a spotlight, all right, on the ground. So this is my little spotlight thing. It's on the ground. that is 40 feet, right, away from a very tall building. On this door of this, quote, very tall building, walks out a what? We're still in the South. This is what they look like. Let you guys know about it. Woman. All right. That is the dress. These days, you never know. 6 foot tall woman. There it is. Now, she's walking directly towards the light, right? So she's walking this way. At what rate is she walking? Quote, she's walking at 5 feet per second. They gave you points because so many people screwed this problem up. They gave you points if you could at least draw the situation out, even though you screwed up the math to try to get the answer. It's okay. That's what I'm saying. Go for partial credit. Never leave anything blank. She's walking at a rate of 5 feet per second. And what's happening here is the light is casting, and this is supposed to be a shadow against the building. And so you're supposed to see that little squiggly line. That's her shadow against the building. Okay? The question is this. She's walking 5 feet per second. How fast is the length of her shadow on the building changing when she is 10 feet from the building? When she's 10 feet from the building. So, I'm going to call this part X right here. X is equal to the distance woman is away from building. Does that make sense? So if this is X right in here, what is this 5 feet per second? Notice the units. What is it? It's dx over dt. That's how fast she's walking away from the building. That's how fast X would be changing. Does that make sense? That makes dx over dt equal to 5 feet per second. Does that make sense? Did I lose you guys anywhere on this? But draw pictures and you have to label it. Come up with your own variable. There's another thing that's changing on this problem too. And what is that? And what are we interested in? This right here. I'm going to call this guy Y. And what is this? Y is equal to the shadow. And actually it's her shadow, if you think about it. Does that make sense? It's her shadow. That's what's changing. So in terms of my question here, my question is, what is the rate of change of her shadow changing? Quote, here we're at. How fast is the length of her shadow in the building changing? Shadow changing. What are they asking for? Being Y is her shadow. dy dt. What is dy over dt? When she is 10 feet from the building. 10 feet from the building. How far away is she from the building is X? When X equals 10. There is the question right there. What is dy dt when X equals 10? Here is the similarity between this problem and your web work problem. You've got to see how to set up the equations here. So now I drew this elaborate thing, but what do you see in this problem? I see triangles. This is related rates. Related rates. After you get your picture, look for the geometric shape or whatever to come up with the formula for the equations of stuff you need. I see triangles. You see triangles? I'm going to redraw this as nothing but triangles so you guys can see it better. I see right triangles. This is Y. This is the building. Right here, this was X. This was 40. Are you with me so far? And what is this right here? That's her, and that's 6. And yeah, you're right. These are all in feet if you think about it. But there you go. Does that make sense? I converted my elaborate drawing of light and buildings and stuff to the triangles, because that's where my equations are going to come from. This is constant. Y is changing, X is changing. But here's the trick. Here's the trick right here. I'm going to do similar triangles, because I actually see 2 triangles on this one. I see this triangle, and I see the big triangle. Does that make sense? But they are similar triangles because the angles are all the same. But with similar triangles, I actually need to know this part in here. Could you please tell me how much this is? Very good. The whole thing is how long? 40. This part is x, so therefore how much does this part have to be? The rest of it. That was the trick. This has got to be 40 minus x. What do you guys remember about similar triangles? The ratios of sides of similar triangles are equal. Geometry class, 10th grade. Ratio of sides of similar triangles are equal. So here we go. Y is to 40. This is the big triangle. So let me just draw two more triangles because I have more than enough room to do this problem. This is your big triangle right here. Here is y, here is 40. And this is similar to the small triangle. And the small triangle, we got this. This is 6, and this is 40 minus x. Does that make sense? Do you see what I'm talking about in terms of the small triangle, not drawing the scale, is right here. The big triangle is the whole thing. The ratio of sides of similar triangles are equal. You don't care squat about that hypotenuse. And so many students try to use the hypotenuse and Pythagorean theorem on this thing. There's no information about the hypotenuse whatsoever, and we weren't interested in the rate of change of the hypotenuse or anything. You don't need the hypotenuse. This is not a Pythagorean theorem question. This is a similar triangle set up the ratio question. So, ratio, y is to 40, y over 40, as 6 is to 40 minus x. Does that make sense? Now, what I'm going to do here, remember the question. Question's still right here. We got to find that old dy dt. And don't forget, we were also given dx dt is 5 feet per second. Keep that in the back of your mind. dx over dt is equal to 5 feet per second. It's kind of moving quite quickly there. All right. Here's the deal. I want to take derivative of this equation. But honestly, I hate stuff in the denominator. So what I'm going to do is I'm going to cross multiply, or get rid of fractions, if you will. Multiply by my common denominator. So this is what I get. This would be equal to y times 40 minus x is equal to 6 times 40. Does that make sense? Cross multiply. I'm going to distribute. This would give me 40y minus xy equals, what's 6 times 40? Well, what's 6 times 4? 24, and with an extra 0, it's 240. Now, there's a little bit better equation. This does require implicit differentiation, but that's what related rates are. There's my equation, and what I'm going to do here is I'm going to take derivative with respect to t. Take the derivative with respect to t of this equation. What is the derivative of 40y with respect to t? 40 is a constant. Leave it alone. This is going to give you 40. What's the derivative of y with respect to t? dy dt, the dude we're trying to find. Minus bracket, because this is a product. To take a derivative of product, I'm going to use the product rule. Hold that negative out front because it's going to distribute. What's the derivative of x with respect to t? Derivative of the first, derivative of x with respect to t is dx dt. Derivative of the first times the second plus the first x times derivative of the second. What's the derivative of y with respect to t? dy over dt. There it is. There is the product rule. Derivative of the first times the second plus the first times derivative of the second. And I just held the negative out front. Don't worry, I'll clean them up and distribute that later. However, here's the trick. What's the derivative of 240 with respect to t? 0, because it's a constant. Now, what is it we're supposed to do again? Oh yeah, here we go. Let's go back to this problem here. What is dy dt when x equals 10? And don't forget, dx dt was given to be 5 feet per second. What I'm going to do now is clean this guy up and solve for dy dt. So I'm going to distribute this guy. So this would give me, just writing down here, 40 dy over dt minus dx over dt times y plus x times dy over dt minus, thank you, equals 0. I distributed the negative. Just pay attention to what I'm doing. All right, so here we go. Plug in what you know. So this would be 40. dy over dt is what we're looking for, minus, this is dx over dt. What's dx over dt equal to? 5. Times y. Okay. We'll figure out y in just a second. What's x equal to? We're supposed to find dy dt when x equals what? 10. So x is 10 times dy dt equals 0. I just need to figure out what that y is right there. What would y have to be? Well, go back and plug it in. You see your constraint equation right here? This equation before we took the derivative? We got y over 40 is equal to 6 over 40 minus x. What was x equal to in this problem when we're trying to calculate these numbers? X was 10. So I'm going to plug it in here. Y over 40, that's a y there. Y over 40 is equal to 6 over 40 minus 10. So y is equal to 6 over 30 times 40. What did I do there? Well, 40 minus 10 is 30, right? And then I just multiply by 40 on both sides. So I cleaned it up and I'm doing some algebra. So what do I get for y? Well, time for a calculator here. Y is equal to 6 times 40 divided by 30, which is 8. Does that make sense? So I'm going to plug in 8 right in here. Let's get your equations. 40 dy over dt minus, what's 5 times 8? 40 minus 10 dy over dt equals 0. Have I lost you guys anywhere? All right. Solve for dy dt. Combine like terms. What's 40 dy dt minus 10 dy dt? 30 dy over dt minus 40 equals 0. You can go ahead and solve for it. What do you get for dy over dt? Add 40 and divide by 30, and what do you get? 4/3 what? What's my units? Feet per second. So the answer to the question is that dy over dt, the rate of change of a shadow, is 4/3 feet per second. And there is my solution. And it's a twist on the same problem that you guys had on web work and stuff. Okay? I hope this has been helpful. Like I said, don't let this exam be the only exam you guys look at. There are tons of exams online through the math department's website. You guys can go to those things. Gray's Bookstore has solutions to the most recent exams. I've also, in my class, I've posted some videos of me going over these things. So make sure that you guys look at a lot more exams and get more formulas, because there's a lot more to these things. What did you guys think about this exam? Was it that hard? Oh, that last problem was questionable, but mostly easy. What do you think the class average on this exam was?
90.
No. Wasn't a 90. Wasn't an 80. Wasn't a 70 either. About a 65. 65, 66. Why? Because some people leave things blank. And when you leave them blank, there's no hope for partial credit. You guys know something. Write it down. Always write down something. See you guys next time. I'll see you guys tomorrow at 7:30 in the morning.